In this video, I'm going to talk to you about some properties of quadratic equations, and one of them is going to be the discriminant and how you can use that to find solutions of your graph. And so we have a couple blanks up here in the reading, and so I want to go through those first before we actually use the discriminant. So a quadratic function is going to be a function that can be written in standard form, and it's going to look like this. And a quadratic term plus a linear term plus a constant. And what makes it a quadratic is that your highest power term is a square term. And so your graph shape is going to be a parabola. And so that looks kind of like this. So this is what x squared would look like. And your a cannot be 0, the coefficient, because otherwise you'd have no x squareds, which would not mean a quadratic equation, it would mean linear. And so you got to have a square term, meaning your a needs to be 1 or another number. It could be negative, but it cannot be 0. And then for the second bullet point here, it says solutions of a quadratic equation can also be called. So solutions have other names, such as roots. They are also called zeros or x-intercepts. And these are the places where your parabola, specifically x-intercepts, will touch the x-axis, and that's what we're going to be looking at here. Now, in the quadratic formula, within the formula itself, there's a piece called the discriminant. And the discriminant is actually very useful for quadratics. So without having to find the whole quadratic formula, just this one piece, the b squared minus 4ac piece, this is used to determine the types of roots that you would have. And there are 3 types, so I'm going to fill those out on our notes here. So if your discriminant is a negative number, then that means you will have 0 solutions, no solutions, meaning no x-intercept. If the discriminant is the number 0 is a 0, then that means you would have 1 solution, 1 place where your graph touches the x-axis, kind of like this picture here. And if this piece of the quadratic is a positive number, then you would have 2 places that your picture crosses the x-axis, or 2 roots, 2 zeros, 2 solutions. And so we're going to talk about that just kind of down here, and then we're actually going to look at some pictures down below. So here it says use the discriminant to determine the types of roots, solutions, zeros, or x-intercepts. They're kind of all referred to the same thing. And so as I'm looking at this quadratic function over here, what I want to make sure is that I have standard form. So let me just make sure I focus over here. It looks kind of blurry. Okay, so again, make sure that you have your function. Normally we have it equal to y, but I'm going to identify that our a is equal to 1, because we have 1x squared. B is equal to negative 3, here the middle term, and C, the constant term with no letter, is equal to negative 4. And what we're going to do is fill out the b squared minus 4ac. And so my b squared, careful here because this is a negative, I want negative 3 times negative 3, and then I'm going to subtract 4 times 1 times negative 4. And so negative 3 times negative 3 is 9, and then I'm going to end up subtracting 4 times negative 4, or negative 16. And these 2 negatives are going to cancel out and make this a positive, and 9 plus 16 is equal to 25. Because this is a positive number, so I wrote down the 3 possibilities here, that means I'm going to have 2 solutions, or 2 x-intercepts. So I'm going to write positive here. Now for my next example, a here is also equal to 1, b is equal to negative 2, and c is equal to 1. So again, that standard form. Now I'm going to fill out the discriminant piece, b squared minus 4ac. My b here is negative, so careful here when you square a negative that you use parentheses. And my a here is 1, and my c is also 1. Negative 2 times negative 2 is 4, and 4 times 1 is 4, which is going to get me the number 0, which means I will have 1 solution. And again, those possibilities I wrote down up here. So if your discriminant is 0, that means your parabola is going to touch the x-axis one time, kind of like this picture there. And now here's one more over here. If my a here is 2 and b is -2 and c is 3, b squared minus 4ac. b times b, or -2 times -2 is 4. And I'm going to subtract 4 times 2 times 3. The 2 times 3 is 6, and 6 times 4 is 24. And 4 minus 24 is -20. Now, if you get a negative answer, that means that your parabola is not going to touch the x-axis. So I'm going to write no real solutions here, because you are not going to have your x-axis, your intercepts happen on the x-axis. It's just not going to touch. So the discriminant, that piece. So now just kind of going backwards with what we just did, taking a look at the picture, tell me what kind of discriminant you would have. So again, the discriminant here, a part of the formula, b squared minus 4ac, can tell you a lot about the graph of a quadratic function and vice versa. If, which is what we wrote down here, see that in the light pink, if b squared minus 4ac is positive, then the graph crosses the x-axis twice, or has 2 x-intercepts. And if b squared minus 4ac is the number 0, then that means the graph crosses the x-axis one time and it has 1 x-intercept. And then the last one here, if b squared minus 4ac is negative, then the graph will never touch the x-axis, or it will have no x-intercepts. So based on looking at our pictures then, if I see 2 intercepts, then that means my b squared minus 4ac, my discriminant, was a positive. So I'm going to write down positive discriminant. Okay. Now here's another picture over here. It touches the x-axis only one time. So if we have 1 x-intercept, then that means my discriminant would have been 0. And I have 2 more graphs on the next page. If your parabola never touches the x-axis, then that means that your discriminant would have been a negative. So no x-intercepts means you would have had a negative. And then the last picture, even though it's upside down, doesn't matter which way it faces, or opens, I should say, up or down. If your parabola is opening up or down, it won't matter. If you have 2 intercepts, that means your discriminant, do you remember, is positive. There we go. Okay, stay tuned. In the next couple videos, we are going to actually be using the entire quadratic formula. So if you weren't sure what the discriminant was, it's the piece that goes under the radical. And that's what you add and subtract. And so when this is a positive, you're going to get 2 answers because you're going to be adding a number and subtracting a number, so hence getting 2 different intercepts. But if that number was 0, if you add and subtract 0, you're only going to get 1 number. And if that discriminant inside of that square root is a negative, then you would have no solution because a square root of a negative doesn't exist. And that's why those connect to your picture. So it just can kind of help you, without having to do the entire equation, get an idea of your quadratic formula. It can get you an idea of how many intercepts your graph has just on that little part of the formula, the b squared minus 4ac. All right, stay tuned for the entire equation coming up next.